All right, guys. Sorry, this is an unexpected day away for me, so I apologize if this is a little janky, but we're just going to have to live with that together. So today we're going to start our final unit, which is all about Earth's dynamic climate. I'm going to try and go through this note with you, and we might do so in a fairly quick manner. So I'm going to call you all the way back to grade 9 science and remind you that we can think of the Earth, this rocky thing, as a series of spheres, right? The Earth itself, we think of as being a big rocky ball, and we refer to that as the lithosphere. The rock, soil, the core, the mantle, the crust, all of that stuff that makes up the Earth is referred to as the lithosphere. But then you know that sitting on top of all of that and sitting in some cases underneath it and around it, the Earth's surface is covered, over half of it, with water, liquid water, and we refer to this as the hydrosphere. And then finally, with the lithosphere, the rock and the soil that makes up the Earth itself, the hydrosphere, we have all of the gases, the oxygen, nitrogen, water vapor, carbon dioxide, all of that. And that, of course, is called yes, very good, the atmosphere. So atmosphere is the collection of gases that surrounds planet Earth. But in the midst of all of that, we of course also talk about the living things on Earth. We refer to this as the biosphere. And this ranges everything from tiny little bacteria to giraffes and carrots, right? Like just every living thing you can possibly imagine makes up the biosphere. The reason we take the time to mention this is it's going to help us kind of conceptualize what we talk about when we move on. So from here, what causes our weather? Because this unit is about climate, and there's a difference between climate and weather, but you should see them as being related. So when we talk about the weather, we're talking about going outside and the temperature, right? What temperature is it today? Rainfall. Is it going to rain? Is it going to be windy? Is it going to, is it going to rain? Is it going to snow? Is it going to sleet? Is it going to hail? Wind conditions. Humidity. Pressure in the air. All of these things are what we would consider to be the weather. If you ask somebody what's the weather like today, they're going to be talking mostly about these things. There's probably some other things I'm not thinking about. If you lived out on the ocean, you'd probably talk about like wave times and tidal times and things like that as part of the weather. Not something we think about as much living in Welland. Though I guess out on Lake Erie, we certainly think about what the waves are like every day. So what causes this? And the answer is that our weather is functionally solar in nature. And what I mean by that is that we have the sun, and the sun shines rays of light in all directions. And of course, rays travel in straight lines, and they make their way to the Earth. And as a result, at any given moment, half of the Earth is lit up and is receiving solar radiation from the sun, and half of the Earth is in darkness at any given time. So the rays of light that strike the Earth are always striking half of it. And what that means is that one half of the Earth is being heated directly by the sun, while the other half is being cooled as heat escapes from it. So rays of light strike the Earth, warming its surface, atmosphere, and hydrosphere. The side facing the sun is warming. While the side facing away is cooling. So here on this side, we would see the temperature going up. And on the other side, we would expect to see the temperature going down. This causes weather patterns. Hot air rises. Cool air settles. Creating pressure differences, which give us wind. Because the Earth is tilted, these effects are different at different latitudes on Earth and in different times of year. And that would go back to grade 9 science, right? I wonder if I have one of my grade 9 classes open on here. I do, right? So when we talked about space in grade 9, you would have talked about how the sun shines on the Earth, right? And as Earth spins on its axis, we get different times of day, right? Midnight is when we're on the other side from the sun, dawn when we're coming up around, noon, and then sunset. So you're going to heat up and cool during the day, but also as you're rotating around because of this axis, the equator is always getting full sunshine, but the northern hemisphere per part of the year is facing away from the sun. We call that our winter. And then as the Earth rotates around the sun, the other half of the year, the northern hemisphere is facing towards the sun. And so we call that our summer. And of course, it's reversed in the south. While the north is facing away from the sun, the south is facing towards the sun. So they're in their summer. And this is why in Australia, it's midsummer when they have Christmas. And in July, they're in midwinter, right? They have the opposite seasons that we do, if you recall that. This is just scratching the surface of why we get weather. We also get water evaporating, right? And water evaporating makes the water move up as well. So I'm actually going to put that up here as well, or down here as well. You could put it anywhere you want. So water also evaporates into the atmosphere due to sunlight. But that water won't stay in the atmosphere forever. So it will come down later in different places possibly as either rain or snow or hail or just dew. So this leads to rain, snow, hail, dew, condensation, etc. Things like that. You could study whole courses. You could do a whole degree on weather. We're not going to do that, obviously. We're just scratching the surface. But the biggest, most important thing to understand is that fundamentally we have weather because of the sun, because we have all this solar radiation blasting our planet all the time, and that interacts with the air and with the water on our planet. And it causes the air to move. We call that wind. It causes the water to move. We call that evaporation, or we call it moving the other way, rain or snow or sleet or things like that. And because of how we're pointed at the Earth, sometimes we're hotter and sometimes we're colder, right? So we get differences in temperature, differences in wind movement, differences in rain, depending on those things. So that's weather. But this unit isn't about Earth's weather. It's about Earth's climate. What's the difference? Don't all go shouting at once now, but I'm going to assume that, I don't know, let's say Emily got it exactly right. When we talk about climate, we're talking about average or normal weather conditions over the course of a year. So the climate describes the pattern of weather for a given environment. Right? So for example, in southern Ontario, we have summers where it is warm, right? 20 to 30 degrees on a typical day. Fairly steady, fairly regular rainfall. Etc. Things like that. We have predictable winds and things like that. And then in the winter, it's cold, right? We'd expect it to be anywhere from negative 10 degrees to, maybe 5 degrees Celsius on any given winter day. We have regular snowfall, right? And wind patterns and all things like that. I'm not going to describe all of that. And we could also describe spring, fall, etc. So when we talk about the climate, we're not talking about just one day's weather, but we're talking about the pattern of weather or the average weather that we expect in that region. And this can be described for large or small regions. We can even describe Earth's overall climate. So with that in mind, when we want to describe the climate of a place, we have to take regular measurements and we have to sort of look at the pattern of how those measurements change over the course of a year, but also how they compare year to year. There's natural variations. We don't expect the weather to be exactly the same every year, but we do expect the pattern to be the same. You'd be very surprised if it snowed all summer and then was shiny beach or sunny beach weather all winter. That would be functionally impossible. You're not going to see that because we understand how the climate works in Ontario. But we have some years where the summer is very, very hot, and we have some years where the summer is a little bit cooler. We have some winters that are very, very cold and some that are a little bit warmer. Some winters where it snows a lot, some where it only snows a little. But we still can describe the average climate or the average weather by talking about the climate in those places. So this requires repeated measurements over time. Now, this is going to become important because we're talking about Earth's dynamic climate. And what the science tells us is that our climate has been changing a lot recently and that we've had rapid changes in climate. You've probably heard of this, but in my lifetime and yours, the global climate has been changing. It has been increasing. On average, Earth is getting hotter. It's important to understand that, just like for a person, if you are a couple of degrees Celsius over normal body temperature, what's regular body temperature?
36.5 to 37.5.
So normal human body temperature is 36.5 to 37.5 degrees Celsius, and a fever would be what? Just a couple of degrees over that?
38 or higher.
Yeah, anything 38 or higher is a fever, and if you get just a couple degrees beyond that, a fever could be considered deadly.
Yeah.
Likewise, if your body temperature drops just a couple of degrees, that's something called hypothermia, and that's very dangerous. So for a complex system, small changes can be really meaningful. So just be aware of that when you read about climate change, it doesn't mean that next year the temperatures are going to double or something like that. The Earth is a really, really, really big place. So even when we say changes are happening really fast, we're not talking about them happening so fast that you're talking about doubles or anything like that. But the climate is changing. Why? So Earth's climate has been warming. And by the way, that's not relative to history. Like in the past, like in the age of the dinosaurs, the Earth was much warmer than it is now. For much of Earth's history, it was much warmer than it is now. So we understand that these things change over time. But Earth's climate has been changing, has been warming rapidly over the last couple hundred years. And so the question is, why? Why has Earth's climate been warming for about 200 years? And the answer has to do with how it is that we trap heat from the sun. And this is something called the greenhouse effect. Don't draw this. A greenhouse, if you've ever seen one, is a building with walls made of glass, and you grow plants in there. This is my plant. These are the worst looking plants anyone's ever drawn, but that's okay. So we draw plants in there, and when the sun shines in, the sun shines on them, but even on a cold winter day or a cool fall day, the heat can get in, but then it gets trapped inside. The heat can get in, but it has a harder time getting out. So inside the greenhouse will warm up, even though outside it gets cold. Because outside, most of that heat is able to escape. But here, the wind doesn't blow through the greenhouse. It's kept sealed. And so that hot air stays inside, and it warms your plants up. It lets them live even in conditions where outside they wouldn't live. My wife has always wanted to build a greenhouse in our backyard. I want a pool. But anyway, we have neither. So why does this work? Or what does this have to do with Earth? Well, you have Earth. And like we said, as the sun shines on it, sunlight comes in. And believe it or not, and of course you should believe it, when sunlight shines in and hits the Earth, well, you know that when light shines on an object, some of that light can be pass right through, but the Earth is not like a big piece of glass. None of the light passes through. You know that it can be absorbed or that it can be reflected. And as it happens, the Earth reflects a bunch of the light. So light from the sun reflects back into space. And depending on what the material is on Earth, sometimes a lot of it can be reflected. Off the surface of the ocean, something like 40% of light gets reflected back into space. Snow and ice reflects something like 90% of light back into space. You've probably experienced this if you ever stepped outside on a really snowy day and it looked really, really, really bright white to the point where it kind of hurts your eyes. So a lot of the light that shines on us from the sun actually just gets reflected back out into space, which means that that heat is lost. So the Earth's albedo, which is how much light it reflects, the word for that is albedo, not to be confused with different terms. The Earth's albedo, how much light it reflects, results in a lot of sunlight, and therefore heat, reflecting back into space. The gases in our atmosphere are able to absorb some of this light. Heat. But some gases absorb more than others. Carbon dioxide absorbs heat especially well. As such, more CO2 in the atmosphere equals more heat absorbed from the sun. So this has always been true. Again, if we look back at the dinosaur era, we know that there was a lot more CO2 in the atmosphere then than there is now. And we know that as a result, the Earth was a lot hotter then. During the dinosaur era, for most of it, there were no polar ice caps. They were completely melted. So water levels were much higher. There was less land on Earth. And average global temperatures were much higher than they are today. In the years since then, that's hundreds of millions of years ago, a lot of that CO2 has been absorbed. A lot of it by water, a lot of it into rock, those places in rocks where it's reserved, and a lot of it in the form of fossils, literally in the form of dead matter that died and is buried underground, and that carbon is captured there. So as a result, the Earth we live on today is actually a lot cooler than the Earth's been for most of its history. Of course, the greenhouse effect is a good thing. The greenhouse effect isn't a bad thing per se. In fact, life on Earth depends on it. But like anything, too much of a good thing is a bad thing. So CO2 absorption of heat in the atmosphere keeps our planet warm, which is necessary for life. But we have begun releasing large volumes of CO2 into the atmosphere in the last 200 years. And that's because when we burn material, organic material, burning organic material releases CO2. And when we say that, when we say organic material, what kinds of things are we talking about? Well, burning wood releases CO2. But of course, if you then just plant another tree, that tree will actually reabsorb that CO2 from the atmosphere as it grows into a new tree. So wood burning is not a big driving force, but oil, gasoline, coal, all of these are what we call fossil fuels. And they're so-called because they literally are the result of digging up oil, which is just decomposed plant and animal matter buried under the ground. And when we burn that, it releases big volumes of carbon into the atmosphere in the form of CO2 that wasn't there before. There are other greenhouse gases too. Methane, which is carbon stuck to 4 hydrogens, is a strong greenhouse gas. This is what we call natural gas. And if you have a leak in your furnace, releasing it into the atmosphere is a strong greenhouse gas. So it's used in furnaces, gas stoves, water heaters, etc. in our homes. You probably have a gas line to your home. It's also released by livestock. So farm animals, not to be crass, but when they fart, they release a lot of methane, and it may seem ridiculous, but actually the fact that we have large numbers of farm animals means that we're releasing a lot of methane there. The result is that greenhouse gases are increasing in our atmosphere. Greenhouse gas concentrations are increasing. Which is driving global temperatures up. For today, that'll be it, and I'm not going to leave you with a task to work on today after this. I think listening to me drone on is sufficient. You can use this time to work and get caught up on stuff you need, or if you've got a culminating for another class. And we're going to work with this tomorrow. We're going to do a few little, we're going to do another note, but tomorrow actually we're going to do a little hands-on activity where we look at where some of this information comes from. So thanks for bearing with this lesson today. Miss you guys. I'll see you tomorrow. Ciao. Have a good one.